Hello, students. Hello and welcome to Unacademy. And this is India's largest learning platform. So, how to get India's largest learning platform? This one. Okay. So, before starting, let me introduce myself. Myself Sunil Manjani, 15 plus years of teaching experience. I mentored thousands of students for GATE ESE and semester exams. Cracked PSU exam myself like GATE HL, MARDISCOM, MARIO. So how to get this Unacademy learning app? Okay, how to use it? So go to Google Play Store or App Store and type in Unacademy. You'll get Unacademy learning app. Okay, install this app in step 2. Okay, in step 3, when you register this your mobile number and register on this register with some permission, you will be asked to go to manage goals. Okay, where you can select GATE and ESE. Step 4, click on the subscription type. Suppose you are clicking on plus, you get subscription button in step 5. Okay, just click on this. You'll get two options, that is plus and iconic. So plus subscription is for 12 months it is costing you 27 to 25. For 18 months it is costing you 34 650. Okay. For 24 months it is costing you 39 600. Okay, you can further get discount by using my code SSM10. Okay, you can 10% discount. Iconic subscription will give you 12 months or 45 to 25 and 24 months for 600. Of course, all plus and iconic subscription will have their EMI options. Okay, you can get further discount of 10% using SSM10 as the code. Okay. Now, what is difference between plus and iconic? In plus subscription, you get India's best educator, interactive live classes, structured courses, and PDF live tests and quizzes. Okay. What is iconic? Iconic subscription, you will get all the features of plus, all the features of plus. Also, you will get personal coach, personalized test analysis, study planner, preparatory study material, etc. Okay. So this much you get on plus subscription. Okay. So let us start with our topic. Okay. Today's topic is programming in Matlab. Okay. So suppose we'll enter into program in much details. Okay. First of all, okay. So let me introduce you some concepts here. Okay. So you can see that if I say that x equal to 3 and y equal to 2, and if I say a equal to x star y, so what I will get? A equal to 5. Okay. Now if I say x equal to 1 is to 5 and I say a is equal to x star y, so what I will get? If I put x equal to, I will get 1, 2, 3, 4, 5, like this matrix. If I put a, then I will get a equal to x star y. X first value is 1, y is 2, so this is 2, then 4, then 6, then 8, then 10. Will it be like this? No. Okay. So let us see what it will be a equal to. Okay. X value is 2. Okay. X star y. Okay. So you will get this 6, 8, 10. This is correct. Okay. So you will get 2, 4, 6, 8, 10. Now I will say y is equal to 1 is to 3. So what I will get? If I enter y, I will get y equal to 1, 2, 3. Like this. Okay. So y equal to 1, 2. If I say now a star y, see that sorry, a equal to x star y, I mean to say. Okay, x star y, I will write down this once again. A equal to x star y. So 2. So what is this? X equal to, what will I get? See here, whenever I am operating a matrix operation, okay, what is the size of this? One row, 3 columns. This is y. What was the last value of x? This is last value of x. This is x. One row, 5 columns. So x is one row, 5 columns. Star y, one row, 3 columns. So here column of first is not equal to row of second. Therefore, whenever I say a equal to x star y, I will get an error. I will get error. Okay. What error I will get? I will get star inner matrix dimensions must agree. Must agree. Okay. So this is the error. Suppose I will say y equal to linspace 1, 3, 5. What I will get y? This is first value, this is last value, these are 5 numbers. Okay, these are 5 numbers. Division. So last value minus first value divided by 5 numbers I will get. Okay. So this is 2 by 5. If I say 2 by 5, this is 0.5. 0.4. This is for 5 values. Now see that number are this, suppose this is 1, 3 numbers, 1 2 3. Okay, 1 2 3. I want 5 numbers between 1 and 3. So this will be first number, second number, third number, fourth number, fifth number. How many gaps are there? First gap, second gap, third gap, fourth gap. 4 gaps are. So I will say that last number minus first number divided by number of gaps. That is 2 by 4. That is 0.5. Okay. So if I say I enter this linspace, I will say first number will be of course 1. Next number will be incremented by 5.5. So this will be 1.5. Then 2.0. Then 2.5. Then 3. So first and last numbers are as it is. The just a minute. Sorry. Mm, This is how you get the answer. Now, instead of simple multiplication, I perform element by element multiplication. Element by element multiplication. X dot star y. So this is the element by element multiplication. What was X? 1 2 3 4. What was Y? 1 2. Oh sorry, last value was Y was 1.5. Sorry, let us rub this with the razor. First value was Y 1, Y is 1.5, 2.0, 1 2.5, 5. So element by element multiplication, when I do dot star Y, I'll multiply first element by first element, second element by second element, third by third, fourth by fourth, fifth by fifth. So what I will get? A is equal to 1, this is 3, this is 6, 4 into 2.5 is how much? 10, 3 into 5. Okay, so this is element by element multiplication. Okay. Now let us see that y is equal to 1 is to 3. Simple. Okay. If I enter x, what I will get? What was the last value? 3, 4. If I enter y, what I will get? Y equal to 1, 2, y equal to 1. Okay. Suppose I write down the function new x comma new y is equal to mesh grid x comma y, x comma y. So x is number of columns, y is number of rows. Sorry, x is number of rows, y is number of columns. How many number of columns? See the last value of x, 3. So 3 number of columns. Number of rows. How many number of columns? See the last value of y. This is the fifth element. So 5 columns. So 5 columns. Yes. Okay. So if I hit this, hit I enter here. Okay. Hit I enter here. I will get new of x is equal to 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. Again 1, 2, 3. So 3 rows I will get x, 5 columns I will get. Okay. So what will be next value? New underscore y. New underscore y. What it will be? New underscore y. It will be 1, 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3. Okay. So I will say that if I put a is equal to new of x dot star new of y, what I will get? 1, 2, 3, 4, 5, element by element, 2, 4, 6, 8, 10, 3, 6, 9, 12. Okay. So this is element by element for new mesh grid. Okay. So we'll see one example. Free falling object. Let us see. Okay. This is some object. Let this is dropped from the height, some height. From some height. Okay. So distance traveled at particular time. Suppose at this time, what is the distance traveled? Distance traveled is equal to half gt square. Distance traveled is equal to half gt square d is the distance, g is acceleration due to gravity, t is equals to time. Okay. So we'll solve this with 5 steps we know. Okay. With 5 steps we know. First step is problem statement. So what is problem statement? Find distance of free falling object. Okay. Second is input output. Input D. Okay. Suppose time t we are getting a matrix of 100 values, 0 to 1 to 100. Okay, so this is second step. Third step is hand example. So d is equal to half gt square, half into 9.81 into t square. Okay, we want distance traveled up to last point. 100 square. What it will be? 9.81. 4.905 into 100 into 100. 490.5 into 100. 490. Sorry, 50. 49050 meters. This is hand example. Fourth one is Matlab solution. Comment I will say distance of free falling object. Okay. Then I will say clear all, then CLC. Okay. So I will say figure 1. Okay. First I will define the constant d equal to 9.81 meter. Sorry, don't need to write meters. The program. Okay. T is equal to 0, 10, 100. Okay. 0, 10, 100. So I'll say that m is equal to, sorry, m comma t is equal to mesh grid g comma t. So g is number of rows 1 and t will be 100. Okay. So if I do this, I will say d is equal to half star G star T dot cap 2 GT square. Okay, so this will be my program. This will be my program. I need to plot one subplot 2 comma 1 comma 1. So plot D comma D. Okay, so this will be the plot. Now this is okay. What we will do is we will also do same problem for different planets. Different. Now G value here planet and G value Mercury G equal to 3.7 meter per second. For Venus G is equal to 8.87 meter per second. For Earth G equal to 9.8 meter per second. Where for Mars G is equal to 3.7 meter per second. Where Jupiter G is equal to 23.12. Saturn G 9 meter per second, and so on. First we will consider only these two, 3.7 and 8.87. Okay, so straight away we will write down the program. Okay, program is clear all CLC. Okay, so G capital G is equal to first two planets 8.87 and 3.7. Capital T time, this is 10, this is 100 suppose. So we'll map this G and D in tier 2 matrices. G comma time T is equal to mesh grid G comma T. Mesh grid G comma T. D is equal to half into G dot star T, because G is now a vector, dot cap 2. So we'll see plot T comma D. Before that we'll introduce subplot 2 comma 2 comma 2 comma 1 comma 1. So plot T comma D, capital T comma. Okay, then we'll put title. Okay, distance traveled by distance traveled on planets during bracket close. This title x label is equal to time in seconds, y label distance in meters. Okay. Then we'll again plot another subplot 2 comma 1 comma 2. We'll plot a logarithmic plot log t comma m power. Therefore, we'll plot log t comma d. Sorry, x label again time in second, y label distance in meter. Okay, distance in meter. Let us see. How we can do it in Matlab hands on. So let this open. So let this open. Okay, we'll wait for some time. So this is Matlab window. Okay, so let us write the program one by one. Okay. So let us see a new script. Distance traveled on planets by during free fall. During free fall. This is the comment. This will not be executed. So clear all CLC. Okay. Then we'll see capital G is equal to 3.7 comma 9 point, sorry, 8.87. 8.87. Capital T is equal to 0, 10, 200. Sorry, 100. This is capital. G comma small t is equal to mesh grid G comma t. D is equal to 1 by 2 dot star t dot cap dot star t dot cap 2. Okay. You see subplot 2 comma 1 comma 1 plot t comma d plot t comma d title distance traveled on planets during free fall. During free fall. This is the title of the plot. X label is equal to time in second. Y label distance in meters. This is save. Let us save this in an Unacademy folder. This F, this Unacademy folder, this is Unacademy folder. So free fall. Save. Run. You have to change the folder. Go to Matlab command window. On the top of that you will find this folder. So it is in Unacademy. Free fall. I'll write down free. So this is executed. Let us wait for the plot. So you can see free fall distance during traveled on planets during fall. Okay, so distance traveled by the planet. Let us modify the program. Okay, we'll write down same subplot. Subplot 1 2 comma 1 comma 2. Plot TD x label distance traveled on the first subplot is same, plot is same, the subplots are different. I will not write down title, x label, y label. I will write down. Let us see what we are. Two subplots. We are getting two subplots. Let us make some modifications. Let us make some modifications. In the program, let us do one thing, that instead of simple plot, let us do log plot. Save this. Run this. You can find the value. This is straight line. Straight line. This is subplot. Let us see the program. Revisit this program. Let us modify this. We are not multiplied G. Okay. So let us save this. This is a modification. So now you can see. You can see for different planets. For G now we have got two values. For different planets you can see. So let us see now. If I make a modification for all the planets, modification in G, (1.6) is for moon, value of G, again 3.7, then for Jupiter 23.12, okay, then for Saturn 8.96, okay, for Uranus 11.0, for Neptune it is, for Uranus it is 8.69, 8.69, for Neptune it is 11, for Pluto it is 0.58. Now we'll make some changes in the plot. Okay. So up to this plot T comma D there is no change. Then we'll write down legend. First Mercury, second Venus, third Earth, fourth Moon, fifth Mars, sixth Jupiter, seventh Saturn, then Uranus, then Neptune, then Pluto. Bracket close. These are legend. Title is distance traveled on planets during free fall. X label time second, Y label distance in meter. Subplot 212 log T comma D time distance. Okay. So this is this will be figure 2. Okay, this is figure 2. I will say figure 1. Let this be figure 2. Y label, X label, not log. Okay. Let us see a other figure. Figure 2. Okay. Plot a mesh plot. D comma T comma T. X label acceleration due to gravity Y label time in second, Z label distance in meter z level. Okay. Title of this is surface plot of distances traveled on planets. Okay. Let us modify something. Figure 4, figure 3 rather. Okay. Bar chart of maximum distance. Maximum distance. Okay. Title distance traveled. Maximum d is how much? 100, isn't it? Traveled in, that means maximum distance in a maximum time. Maximum time is 100. Traveled in 100 seconds on the planets and the moon. Okay. X label planet, Y label distance. Okay, so this is run this program. See the figures. Okay, there is one problem. Figure 1. Okay, see this. The surface plot. This is figure 1. Okay, so you can find this very interesting if you plot the figures. Okay. This is all about plots. Okay. Let us now move on to our presentation. Okay. Next one is user defined function. User defined function. So in user defined function UDF, okay, what is done is there is a prompting to put a value. To put the value for a variable at command prompt. At command prompt, or rather you can say command window. How this syntax is? Okay, we'll write down z is equal to input, enter a value. Okay. When you hit this, what will happen? Enter a value. will be appearing. Suppose after giving some space, I put 5 as a value and hit the enter, then Z is equal to okay. If you say Z equal to input, enter a value, enter values rather of Z in bracket, okay. So you put, when I hit this, it will display like this: enter values of Z in bracket 7. Okay, then cursor will be blinking. You just, what you do is write down 1 comma 2 comma 4 comma 5, hit enter. What you will get is Z equal to 1 2 3. Okay, user defined input. So let us see some hands-on today. Okay. Z equal to input, single quote, enter a value, enter a value. If I hit enter, enter a value 5. Z equal to in bracket, enter values of Z in brackets. In bracket. Rather, I am not written down input. Okay. Write down 1 comma 2 comma 3, 1 comma 1 comma 2 comma 3, 4 comma 5. Okay, so this is the value. We'll find one area of a circle like that. Okay, program, we'll see new area of a circle. Okay, so for that, what we'll do is we have to put radius, isn't it, as an input. R equal to enter radius of circle. Okay, After entering, what will do? Area is equal to pi into r cap 2. Okay, so we'll save it. Area, run this one. See the Matlab prompt, command prompt. Choose another input, circle area, circle area. Run. What we'll do is let this be r star, save it. Oh, we are not returning. Then this one is okay. Cap 2. You have to enter radius of a circle. Suppose I enter 5. See, yes. Again, it is prompting circle area. Okay, simple program. This is input option. Okay. Now we'll see what are output option. Okay. So what are output option? Okay. So suppose I have written down value x equal to 1 2 3 4 5, and I will say there are two functions to display the output. So output is displayed by two functions. First one is display function disp. Second one is fprintf. Fprintf to display the output. Okay, we will see display function. I will write down display x. If I hit this, it will enter 1 2 3. Okay, so let us see hands on. Okay, so one more program, that is, I will write down straight away in the command window. Let us see. Okay, CLC x equal to 1 space 2 space 3 space 4 space 5. Okay. So this is x equal to 1 space 2 space 3 space 4 space 5. Rather I will say x equal to 1 space 2 space 3 space semicolon. I will say display x. So 1 2 3 4 5. I will say display the value in x matrix are okay, semicolon. Display disp display the value in x matrix are. So this is right. Rather I will say okay, like this you can display, or you can say that this is this is Unacademy station. It will be this CL. There is one more function, number to string. number to string. Let us see what is this function. We have got x value already. Okay. So num to string in bracket x bracket x. So display number to string value in bracket x square bracket. Hit enter. Just a minute. Okay, like this you can find out number to the value in x matrix are 1 2 3 4 and 5 by using number to string value. Okay. You can also write down this as a is equal to the number value in the array are number to string like this. Okay. Value in the string, value in x matrix are like this. If I say double click on this a matrix, okay, choose column, size, choose column bytes, okay. I'll again write down a is equal to number to string like this. Okay, see the values, how many values are, what are the bytes, like that. Okay, so this is display function. Okay. Let us now go back to our PPT. Okay, let us now see what is fprintf. Fprintf. Okay, so this will be equal to fprintf format dash string comma variable comma dash dash dash. This is a general form. This is a general form. Example: temperature suppose is equal to 98.6. Printf the temperature is, this is a floating number. We'll see what are these floating numbers in integers. Percentage f, percentage floating in degrees, any decimal is floating. Temperature, okay, can tell the temperature. If you hit this, enter 98.61234 degrees Fahrenheit. See here, this value will be displayed here on in place of percentage. Rest of the sentence will be printed as it is. Okay, which value will be printed? You can see temperature. Okay. Okay. So see here. I will say f printf the temperature. Before that, what I will do is, just a minute, I will say temperature equal to 98.6. Temperature equal to 98.6. Then the temperature is percentage f degrees Fahrenheit. Okay, comma temperature, okay, temperature is 98.600000 degrees Fahrenheit. Again, if I want to write down one command, you can see this is in continuity. Okay, temperature 100.1. So this is in continuity. What should be done? Okay, simple thing is, after writing down this command, okay, just at the end, what you do is, at the end of this, before comma, before single quote, write down backslash new line, then you press enter. Temperature is 100.1 degree Fahrenheit. In new line, another command will be executed. Okay, so like this you can see So field format, what are typical field format? Okay, typical field format. Typical field format. Percentage F, fixed point or decimal notation. Percentage F, percentage E, exponential notation. Percentage G, whichever is shorter. Percentage F or percentage. Okay, out of those whichever is shorter. Okay. Next we'll see special format command. Special format \n, this is called as line feed, new line. \r, carriage return. \t, tab. That means if I introduce this, my result will be displayed after one tab length of space. Okay. \b, backspace. Okay, backspace. Okay. Now let us see some hands-on example. Very interesting. Okay. What we'll do is create a file. Okay. Temperature. Okay. We'll put temperature equal to 98.6 space 100 space 99.2 space 100 space 99. Space 99.2. Okay. Then we'll say f printf the temperature is percentage 8.2 8.2. Okay, fixed point integer degrees Fahrenheit, and I will say \n like this, then comma temp. Save this one as a temp. TRA temperature. Okay, then run this. See here what are the values. See, because of backslash n, every temperature is displayed one after the in separate line. In separate line. Let's close this figure. Help figure. Let us see what else we can do. We can say patient equal to 1 is to 3. Okay, temperature are already there, so we'll say history equal to patient semicolon temperature. Okay, we'll save this, hit the run button, see the result. Okay, so history you can see like this, it will appear. Let us see how can we write down clearly. f printf patient percentage 4f had a temperature of percentage 7.2 f backslash n comma history save. Okay, f printf. Okay, let us see. Patient 1 had a temperature of this. See here, this is percentage, so we don't want 1.001 so I will say percent d. Okay, save and run. Patient 1 had a temperature of 98.60, then 100, then 99.20. In this way you can format the output. Is clear now. Okay. Okay, this is clearly what is called as Okay, so these are some of the example of what you can say is fprintf and display function. Fprintf and display function. Okay, so clear. So let us now move on to our PPT. Okay, let us see one example. We have seen of free falling object. Free fall. Distance of free fall is half gt square. Okay, okay. So we'll use fprintf input and display function. Display function. We'll use input and output function. So let us see how we can write down clear all CLC G is equal to input enter value of acceleration due to gravity. Okay, single quote close, start is equal to input enter starting value of time. Okay, finish input enter ending value of time. Finish. Increment is equal to input, okay, enter time increment between starting and ending time values. Okay, increment. So t is equal to starting value colon increment colon finishing value. Okay, so let us see. Okay, Okay, so then we'll say D is equal to half star G star T dot cap 2. Okay, table we'll plot is T comma D, T comma D. Okay, that is increment of time and distance. Okay, then we use F printf. Okay, for G of whatever value you put in, suppose star 5.1, sorry, percentage 5.1 F meter per second square. Okay, then backslash n following distance was calculated, backslash n quote close, then comma G, like that. Okay, like that you need to find out. Okay, so display distance traveled in free fall. Okay, again distance time, single quote time in seconds, distance meter, like this. Okay, then you say f printf is equal to percentage 8.0 f percentage 10.2 f, sorry, this is f backslash n table. This is percentage f, you can say that this is for time, this is for distance. Okay, time and distance, because table has two values, time and distance. Okay, go on to some hands-on. Let us see. Okay, some formatting we will see. How long did it take? So you can see that we can format the statement in different forms. Okay, so we can arrange the input values, we can arrange the output values in more readable form like a proper output. Okay, so facing some problem with this PowerPoint. Okay, okay, so you will get the final output for that one is equal to final output if you go on prompting. Okay, so this will be distance traveled in free fall, time in second, distance in meter. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Distance is equal to 0, 80, 320, okay, 720, 1280, 2000, 2880, 3920, 5120, 6480, and 8000. So this is proper format, you can see. Okay, so we'll complete this today. Thank you very much. So before going on, let us see how you can unlock free plans on Unacademy. Use Unacademy learning app. Okay, install it. Go to daily interactive live classes. Okay, select your goal, GATE and ESE. Okay, select the subscription. You will be directed to some free videos available, free courses available. Okay, if you say this is free courses, if you want to uh, view this free course, okay, click on it. You will be asked to enter an invite code. Put an invite code of SSM 10, then press unlock. You will be free to you will be allowed to access this course for free. Okay, so this is how to unlock free plan on Unacademy. So guys, that much from here. Go to YouTube, comment, subscribe, and like our channel. Okay, also hit the bell icon for further notification. Also join our Telegram group for latest upcoming videos. Thank you very much. This is Sunil signing off.